Hello everyone, how are you doing? Happy Thursday. Today we are looking at the product rule of derivatives. I should add that in there. Of derivatives. The product rule is a really important rule. This is a rule that absolutely 100% has to be memorized, not just for the test on this later when we get there, but it needs to be memorized throughout the whole year. We're going to reference back to it over and over and over again. It's going to show up in multiple ways on your AP exam. So it's a really important topic, and it's just a rule that needs to be memorized. So the product rule, right? In product in mathematics, we know means multiplication. Whenever we have two different functions that are multiplied together, and we want to do the derivative of that, it's a little more complex than just doing the derivative of one times the derivative of the other. So let's take a look at this. Let's consider two functions. We're going to call them f of x and g of x, and we're going to take the product of them. So here we have two functions, f of x and g of x. We're just using general terms here. The AP test writers want to make sure that you know this in general form and how to apply it to specific functions like x times sine x or something like that. So if we have two functions, f of x times g of x, and we're going to do the derivative of them. So I'm going to do the derivative of the whole thing here. I have to follow a special formula way of doing this, okay? So, again, I'm doing the derivative of some function f of x times some function g of x. Well, it's going to start with doing the derivative of f. So our answer is going to be, I'll just kind of write it on the board and then talk it through. So our product rule looks like this. The derivative of f of x times g of x is f prime of x times g of x plus f of x times g prime of x. Notice that the functions f and g, the original functions, show up in this, along as both of their derivatives do as well. So we're going to see f prime show up, we're going to see f show up, we're going to see g show up, we're going to see g prime show up. So all of these things show up. That is our product rule of derivatives. That is the general form right there. So we need to know that very well, and we need to know how to apply it. So let's do a couple of examples here for applying the product rule of derivatives. So, let's say I have a function called f of x. Now this can get a little bit confusing here because we have a lot of different f of x and g of x's going on here. What I want you to think about is f of x is just the name of our function here, x cubed sine x. In terms of applying the rule here, we want to think of x cubed as the first function and sine of x as the second function. And we can see that we are taking x cubed and we're multiplying by sine x. Using the formula above, x cubed is like our f of x, sine of x is like our g of x. Okay? So another way you can think about this is if f is like the first function, g is like the second function. It's the derivative of the first times the second plus the first times the derivative of the second. So at some point in time, I'm going to need to do a derivative of x cubed, and I'm going to need to do a derivative of sine of x. But I also the function x cubed and the function sine x are both going to show up as well in my answer. So we're going to end up doing the derivatives of both of them. But notice in that answer, never do we have f prime times g prime. The two derivatives are never going to multiply into each other. So let's think of it this way. Another way of thinking about the power rule with words is derivative of the first times second plus first times derivative of second. So it's the derivative of the first times the second plus the first times the derivative of the second. So let's follow that to find f prime of x. So I'm going to start by doing the derivative of the first function. Right? It starts off f prime, the derivative of the first. Our first function here is x cubed. So think to yourself, what is the derivative of x cubed? Well, that's just a simple power rule. Or sorry, this should say product rule. My bad on that. I'm getting my rules mixed up. So product rule is derivative of the first times the second plus the first times the derivative of the second. So this first function here, x cubed, is just a power rule derivative. The derivative of x cubed is 3x squared. So I do the derivative of the first, and now I need to multiply by the second. Notice it's just the regular second, just g of x in our equation. The second function is sine of x. So this thing starts off 3x squared times sine of x. So we did f prime g, we did the derivative of the first times the second. Now we have to add to that the first function, not the derivative of the first, but the first function, which is just x cubed. And we need to multiply that by the derivative of the second. So we have to do the derivative of sine x. The derivative of sine x is cosine x. And I have completed my first product rule derivative. So again, derivative of the first times the second plus the first times the derivative of the second. Okay, I'm going to put another example up here. After I put that example up, I want you to pause it and then try solving it yourself. Okay, using a different notation here, I'm saying y equals e to the x tan x. Find dy dx. Again, we know this is going to be a product rule problem because I have two different functions that are multiplying together, e to the x and tangent of x. So go ahead and pause here, try to find dy dx, and let's check back in a second. Okay, we're back. Here's what I got for my answer. Is that what you got too? Well, once again, I started with my first function is e to the x, so I did the derivative of the first, which, hey, e to the x is its own derivative. So the derivative of e to the x is e to the x. Derivative of the first, e to the x times the second, tangent of x, plus the first, e to the x times the derivative of the second, secant squared x. Let's try another one. Okay, I switched things up a little bit here. Now I'm saying f of x equals x to the 7th ln x. Now I want you to find f prime of 1. Well, don't be concerned. All we have to do is first find f prime of x, simplify it, then plug in 1 to see what our answer is. Right? Anytime we have to find a numerical derivative, right, a derivative at a point, we just want to find f prime of x first. So we're going to need the product rule here because we have x to the 7th times ln x. We're taking the product of x to the 7th and ln x. So go ahead and pause it, or go ahead and find f prime of x. Pause the video and work on that. Then we'll unpause it, talk about f prime of x. Then we'll find f prime of 1. Here we go. Is that what you got for f prime of x? That's good. F prime of x equals 7x to the 6th times ln x plus x to the 7th times 1 over x. But we can simplify this a little bit before we plug things in. So let's go ahead and simplify this. The first term, 7x to the 6th ln x, doesn't simplify, but we can simplify that second term. That second term, in fact, simplifies down to simply x to the 6th. Right? X to the 7th times 1 over x is x to the 7th over x. X to the 7th over x reduces to x to the 6th. So now I got a nice, easy thing to work with. Now I want to find f prime of 1. So let's go ahead and plug in 1. So when I plug in 1 here, I get 7 times 1 to the 6th. 1 to the 6th is 1. 1 times 7 is 7. But now I'm multiplying by ln 1. Well, we need to know ln 1 has a value of 0. That makes that whole first term 0. So I get 0 plus 1 to the 6th. 0 plus 1 is 1. Okay, let's try one more. And I'll just make one up here. Okay, so here we're saying f of x equals 8x squared cosine x, and we want to find f prime of x. So go ahead and pause it here, try and find f prime of x, and let's simplify it down as nicely as we can. There is a part here to be a little bit careful on, and I'll show you as we do it. So go ahead and pause, try it, and then come back to see the answer. Okay, taking a look here, we do the derivative of the first, which is 16x times the second, cosine x, plus the first, 8x squared, times the derivative of the second, which is negative sine of x. Here's where we need to be careful. A lot of students don't put that sine of x in parentheses, or they just put a little dot for times. That can be a little bit troubling because then it starts the second part starts looking like 8x squared minus sine x. It is not 8x squared minus sine x. It is 8x squared times negative sine of x. So we need to be careful with that. Anytime you have a negative value pop up on a derivative, within the product rule, we want to be very careful, and we can use parentheses to help make it look like more like multiplication. The other thing I like to do is, if I'm multiplying two numbers, right, that 8x squared, which is positive, and that negative sine x, which is negative, I know when I multiply them together, it's going to make a negative answer here. So I like to rewrite this looking like this. I like to take that negative in the sine x that we're multiplying and throw it out front. So really it ends up being plus negative 8x squared sine x. Well, instead of writing plus negative, it's better to just write a minus sign. So this is a nice simplified version here. We get f prime of x equals 16x cosine x minus 8x squared sine x. That's it for today on the product rule. We'll have some practice on this on Monday. But before we get there, I'm going to give you another video tomorrow on the quotient rule. Also a very, very important rule that will help us along the way. Thanks for watching. Take care.